Okay, so a couple of years ago I invented what I think is the fastest subtraction method, the smartest subtraction method, and the most fun subtraction method. I call it chain subtraction, and it's a method where you subtract numbers from left to right. Let me show you an example, or a couple of examples. I just write some random numbers. Subtract them. So maybe I'm not the fastest at the method, but that's just because I haven't practiced it in a long time, because I've been busy with work and stuff like that. But if you learn the method and practice it, you can become very fast at subtracting numbers from left to right. So let's just take another example. And I like to do big numbers, but you can do it with short numbers, long numbers, any number at all. So I just like to do big numbers because, yeah, I don't know, it's fun. So let's subtract again. So we say so that's another one. Let's take another one before I show you how it's done. Put that one over there, and then so let's subtract again. This one is 0, this one is 4, this one is 1. Okay, so I got a bit stuck, but like I said, if you practice this, you can become very fast. I used to be very fast, but yeah, don't have the time to sit and do subtractions all day. So anyways, let me show you how I do it, or this is how I like to show people how it's done. This is not quite how I do it in my brain, but let me show you how it works, at least. So let's take some random numbers. Okay, so the way I do it is, let's say I start with the first number, 2 minus 1, stand on 2 minus 1 over here. And then if this number is bigger than this number, I have to subtract 1. But in this case, 3 is not bigger than 9, so I don't subtract 1. I just write 1. Then we go to the next chain of numbers. And here, 9 minus 3, so we stand on 9 and go 1, 2, 3 and land on 6. And then I look at this row over here, chain, and 4 is bigger than 3. So if this number is bigger than this number, I have to subtract 1. So we go from 6 down to 5. So we write 5. Over here, 3 minus 4. So if we stand on 3 over here, 1, 2, 3, 4, we land on 9. Now we are on 9, but as you can see, the next row has a bigger number down here than this row, so we have to subtract 1, so 8. Now this one, we stand on 4, 1, 2, 3, 4, 5, land on 9, but as you can see, the next chain, the number below is bigger than the number above. It's very simple. So we have to subtract 1, land on 8. 8. Here we don't have any more rows to look at over here. So we just write the result we get. So we stand on 5. 1, 2, 3, 4, 5, 6. So it's 9. So that's the result. Very easy. So anytime you subtract the numbers, if the next row's number that below you have to subtract from the one above is bigger, you have to subtract 1 from your result. But let me show you how I do it in my brain very fast. So I use minus numbers. So this is as you can see, if you just remember that below the 0, 9, minus 1 is 9, minus 2 is 8, minus 3 is 7, minus 4 is 6, minus 5 is 5, minus 6 is 4, minus 7 is 3, minus 8 is 2, and minus 9 is 1. Very very simple, but it's just the opposite. But if you remember these numbers, you can do it very fast in the brain. This is the way I do it with the minus. So let's take an example. So we say anyways, I look at the first chain and I say 3 3 minus 1 or 1 minus 3. I don't know if the how you say it. Anyways, these two numbers. So 3 minus 1 is 2. And I look at this row. 3 is not bigger than 4, so it's just 2. I go to the next row. I say 3 minus 4, that's 1. And I look at the next row. Is 4 bigger than 5? No, so it's just 1. I go to the next row. I say 4 minus 5, that's 1. I look at the next row. Is this number bigger than this number? No, so it's just 1. Then I go to this row. 7 minus 9, that's 2. And then I go to this row, but this row has a bigger number down below, so I have to subtract 1. So instead of 2, it's 1. And this one, now we come to the minus part. 6 minus 9, that's minus 3. Minus 3 is 7. I just know this in my head. If you just remember that minus 1 is 9, minus 2 is 8, you'll be all set. And down below. So minus 3 is 7, and that's our result. Let's take, there is another rule, and that is if two numbers are the same, you cannot use them to check the next number if you have to know if you have to subtract. So let me take an example. So I'll just write some random numbers. Solving this, I'm gonna say 3 minus 1, that's 1. I look over here, this one's bigger than this one, so that means 3 minus 1 is 2. Minus 1, sorry, I'm too fast. So it's 1, because this one was bigger, so we subtract 1. Then we say 4 minus 7, that is minus 3. Minus 3 is 7. So, and then we look over here, and this number is bigger than this number. So it's not 7, it's 6, because we subtract 1. It's very hard to do this and talk at the same time. But I just go move over here. So 2 seconds. So we say and then that's so here we are standing here. So 2 minus 2 minus 3, that's minus 1. Minus 1 is 9. We look over here. Is this one bigger than this one? These are the same numbers, so we cannot use these numbers if they are the same. We must jump to the next one to draw a conclusion. So we say 2 minus 3, that's minus 1. Minus 1 is 9. But we look over here, same number, jump to the next one, same number. And over here we find if we have to subtract 1. So you just have to go to the row, the chain, where you find your answer if you have to subtract 1. And it just has to be not the same number. So minus 1, jump over here, jump over here. Oh, I can see this number is bigger than this number, so I have to subtract 1 from 9, so that's 8. And then immediately I already know that these numbers are 0, and I also have to subtract a 1 from those two numbers. So it's just, so 8 minus 8, that's 0, minus 1, that's 9. So you can just write 9, 9 every time you see these, and the last number is bigger than the other one. This one 9, and this one we don't have any more to the right to look at, so we just write the result, minus 2, that is 8. So I'm gonna take another example where the number after the same numbers are different, just so you completely understand the method, or maybe you can watch the video again. So 4 minus 2, that's 2. Look over here, this one is not bigger than this one, that means 2. Go over here, 3 minus 1, that's 2, but this number is bigger than this number, so that means we have to subtract 1, so it's 1. This one over here is minus 1. Minus 1 is 9. Look over here, is this one bigger? No, it's not, so it's just 9. We go over here to the next one, 9 minus 8, that's 1. But now we see again we have the same number over here, so we cannot use this one to know if we have to subtract 1. We go to the next one, but as you can see, the next row, this is what I want to show, the number is not bigger below, so we don't have to subtract 1, so it's just 1, 0. And this one, we go over here, 6 minus 5, that's 1. Look to the right and you see that 9 is bigger than 7, so we have to subtract 1 from 1, that's 0. And then the last one we say that's minus 2, 7 minus 9, that's minus 2, minus 2 is 8. So hopefully you understand the method now. If not, go back, try to learn it, and spread the method. I invented the method, but I just want everybody to learn it and to become better in math, because at subtraction, because I invented this method when I was sitting on the toilet and thinking about why it has to be so hard to subtract in the head, because you have to write the numbers up above, you know, with the tens, and draw a line over them. It's too much. This one is very simple. You can do it with giant numbers, and you only calculate one row at a time and peep over at the next row if the number down below is bigger than the number above. You don't even have to use your brain to use this method once you know that minus 1 is 9, minus 2 is 8. If you just remember that, and also the rule with the same numbers, that you have to jump to the next one to find if you have to subtract 1 or leave it. So share the method. I don't need you to mention me. You can use this method, just get it out there in the world. That's what I want. So hopefully you enjoyed the video, and thank you.